Hello, everyone, and welcome to Lecture 6 of the Mechanical Design course from AvengerRobotics. This is the final lecture, and we're going to go over design practices and strategy. Yay, final lecture. What we will cover in this lecture: strategy and research, teamwork and project management, parametric modeling and saving time, and designing for manufacturing and maintenance. So first, we'll go over strategy and research. Strategy. Why care about strategy? Designing without a strategy is similar to fixing a house without knowing the problem. It could be plumbing, wiring, drywall, AC, or pest infestation. If you don't know what you are trying to fix, you have to bring either many tools or multi-purpose tools. If you do know the problem, you can bring the exact tools needed to solve the problem. You don't want to be the guy called in for pest control and bring a wrench. Whacking the hornet's nest with a wrench is not going to end well for you. So this is the same in FRC or anything engineering related. If we know our strategy, we can make our robot be as efficient as possible doing what it needs to do without wasting time, space, and weight on unnecessary mechanisms. So here's a flawed example of strategy. This is our robot from 2023 FRC season. The strategy our robot was built for was too broad. So what essentially we wanted to do was build a pick up from anywhere, drop off anywhere, and do it like moderately well. The issue was that due to a combination of factors, we were able to pick up from anywhere and we're able to drop off everywhere. It's just extremely slowly compared to our peers. So we could have been a lot more effective in competition if we decided to narrow down our focus for strategy. So here's a good example of strategy. This is Team 1746 Autos Robot from 2023. They're a team that's in the same county as us, so we get to know them well. They ended up competing in the Einstein division at Worlds because of a simple and reliable strategy-first design. They could easily drop game elements into the intake and simply extend it out to the outtake. So one thing they would do is there is this like collection part where they'll drop either a cone or a cube down a ramp, and it'll just feed into their robot where that orange intake is. And they can just drive straight over and excavate it. They can't easily pick it up from the ground as much, but they have a very efficient strategy. So how should we strategize? First, you have to look at the problem at hand. In FRC, this means seriously analyzing the game manual, looking for rules, measurements, and most importantly, the scoring matrix. The team needs to figure out what the game rules incentivize, either through points or rules. So when you're strategizing, try to maximize your potential points in game. So if doing one thing is going to take a lot of effort but doesn't give you a lot of points, when you can just score more quickly, you're better off just scoring more quickly in that case. But if doing one thing gives you a lot of points, then you should probably focus on doing that. Then the team must figure out its capabilities. So some teams can make robots that score the fastest with the most points. However, not all teams should. Some teams have succeeded with simple to make robots to them supporting the complex ones. Specifically in FRC, you have to remember that the people that end up making it to first place in the elimination matches are not always the first place qualifying teams. If you're a really, really good support robot that can help the other teams win, you can often actually help your elimination team get the first place, even if none of the three robots are the fastest scoring robot. This makes it relatively feasible for newer teams or less experienced teams actually make it up in the ranks if you just make a robot that's focused specifically on helping other robots. However, if you do want to guarantee getting to the point, if you want to guarantee winning, then you probably want to make sure you have the fastest, most efficient robot, but that comes with experience. So strategy comes first. That's something I want everyone here to understand. You don't design without a strategy, because designing with a strategy is like going to a house without the tools to fix the job. So next we'll go over research. So why research? Well, my answer to that is why solve an already solved problem? During the design stage, we can find inspiration in mechanisms with similar functions. We can find this inspiration from other teams. Many teams publish their designs for outside use. Or we can find inspiration from real-world engineering. So how do you research mechanisms? You first need to know the intended function of a mechanism. Then, especially early in the season, you can try to find real-life machines with similar functions. During the season, try to keep up with the FRC community in order to take inspiration from other designs. So this includes, FRC subreddits or the FRC Discord, or there's also YouTube channels that, show robots that teams have made. There's Robot in 3 days. There's so many different resources you can look at how other teams have been building their robot. Sometimes you can just follow teams on an Instagram account and you see pictures of them. But isn't that stealing? I would admit there is a fine line between inspiration and theft. I think the moral ways to get around this is to make sure that when you look at other teams' designs, you try to customize it, especially if the design wasn't actively shared for public use. If another team's design is an essential part of your robot, you should also probably give credit to that team. It is good to give credit to teams. It makes your team look better. It makes their team look better. It's a win-win situation. Don't be afraid to give teams credit if you use their design. So I said earlier, published design. So here's some examples of those. The most famous one is the published design for public use is Robonauts Everybot. So what Everybot is essentially every year they come out with a competitive, cheap, easy to build robot that newer teams can build in order to compete at a high level in FRC. And they publish this resource along with instructions and resources for building the robot every season, and it's completely free for everyone to use. There are other examples made by teams, universities, and part suppliers as well. Once again, Robot in 3 days is a great example of this. Or sometimes teams like Robonauts will publish what they built for other teams to use. And sometimes you can just ask them, hey, can you show us how you built that? And they'll be more than welcome to give it to you. So researching real-world mechanisms. When researching real-world mechanisms, make sure to understand what each part of it does in depth. Many times machines will be built for a slightly different purpose, but with modification can be made for effective for a robot. So, for example, last year we were looking at, excavators for inspiration for our robot arm. And we realized that excavators use hydraulics in order to, be reliable. So we thought, what if we use pneumatics for our arm instead? However, the problem with excavators is that they're relatively slow, but we needed our arm to be fast. So we had to edit the design a bit. So we didn't use pneumatics for the entire thing. And we ended up caring more about the speed of it than necessarily the strength of it. Any questions? Teamwork and project management. Teamwork. Designing in a team can be a difficult task. So some reasons for that is most CAD software doesn't allow for easy collaboration. Communicating design ideas can be difficult and takes time. And parts designed by different people can have difficulty meshing together properly. So why do it? Teamwork allows us to design more complex mechanisms. We can do it faster, and we can do it in more detail. Designing a whole robot by yourself is extremely draining and should generally be avoided. There is especially common in teams where there's a large disparity in knowledge between the veteran members and the rookie members. It is very common for large portions of the robot to be designed by one or two people, and it can be draining and exhausting for those two people for that season, while everyone who isn't working on the robot can feel bored and can lose motivation. So it's really good if you try to split up the work in designing to multiple people in order to have these benefits stated earlier and just to keep everyone sane for the season. So we want to have teamwork, but we also need to mitigate the downsides. So how do we do it? Making teamwork work. The most important task is to establish clear methods of communication. The design team should be able to communicate clearly to everyone. After that, you should create a shared file management system and a shared design language. So first I'll go over communication. So for communication, our team uses Slack. Other popular options include bulletins or whiteboards, Discord, Trello, or Notion. We'll talk more about this later in project management. So next we'll go into file management. Proper file management and version control is necessary for teamwork. Good news. If you're using Onshape, this is done for you. This is actually a best benefit of using Onshape on your team if you want to do so, because it is similar to Google Drive or Dropbox where it automatically does file management for you. However, if you're using anything else, like us at AvengerRobotics is, you can buy proprietary version control software, but that's expensive. So what are some alternatives to version control software? So what we plan to use, and it might seem excessive, but it essentially does the same thing as version control software. So you set up standard naming conventions for saves. So what I would do is like add a date, a time, and a part. You can try doing like part number stuff. I wouldn't worry about that. Just have date, time, and a part name. And then you can save each file into a folder that's for that day's session. So each day you have a folder and you just save that file into that folder. And then you keep those folders in a shared drive. So Google Drive, Dropbox, etc. That's like the cheapest way without Onshape to use file management. So next I'll go over a shared design language. So a shared design language is essential for meshing systems. So what I mean by shared design language is try to make predetermined ways to mount parts and to use similar sized bits, holes, etc. Essentially, the way people design things, the certain quirks of the design should be relatively similar among all of the design team, just so things mesh together properly. So the reason we do this is that it will allow easy manufacturing, assembly, and will eliminate the risk of redesigning parts. So now we'll go over project management. So what is project management? So everything I stated before actually falls under the roof of project management. The purpose of project management is to effectively facilitate teamwork. This is especially important in robotics due to our time and budget constraints. So for most teams, there are two methods of organizing project management. You can have a project manager, or you can have full team meetings very frequently. I personally believe a project manager is more effective, but we will go over both. So for project managers, a project manager's role is to lead the project and get on the case of everyone on the team. Essentially, they're going to bully everyone into shape. They facilitate communication between members while keeping deadlines and budget on track. In FRC, I would probably recommend to have one member of the design team be both designing and be a project manager. So, maybe like a veteran member or just somebody who's more like social and capable of, harassing people to get things done. They should also double up as a project manager. So next is team meetings. This is the method that smaller teams may use. The reason why is that it's a bit more democratic and it's much easier to like set up. So what I mean by team meetings is at the beginning of each session. So I don't know, like a meeting or anything, like the whole team gets together. Everyone convenes to communicate what needs to be done and how for that session. The problem with this method is that it uses a lot of time and can cause ineffective communication. Our team has done this in the past, and a lot of times it delves into arguments and people not understanding what's happening, and then people don't know what they're going to do that day. It's a giant mess. Having what needs to be done all centralized into one source in a project manager makes things a lot easier. So remember how earlier I talked about communication more? This is where it is. This can be used for project management. For example, a combination of Slack and a bulletin board can allow tasks to be given out and for communication between team members. So what a project manager can do is they can direct message or post in the channel in order to facilitate communication. So they can kind of force people to communicate. This way, when things need to happen, the project manager will facilitate it. But when things don't need to happen, you don't have to have a meeting with wasted time. So what I would recommend for every team is to practice project management. Any questions? Parametric modeling and saving time. So parametric modeling techniques. What is parametric modeling? Parametric modeling is the ability to quickly change dimensions of designs in CAD. It is essential to best take advantage of this feature. Most CAD software includes features like relations, variables, and equations in order to take advantage of parametric design. What are relations? Relations like parallel, equal length, perpendicular, midpoint, etc. can be used to simplify CAD designs. This is essential to make editing designs quicker and easier while maintaining readability for team members. For applications where a ratio or angle remains consistent, independent of dimension changes, I recommend to use relations. Variables. Variables allow you to change one value and affect multiple dimensions. This is extremely useful when you have multiple dimensions that must be the same length. Like relations, these keep designs cleaner and less likely to break. Variables are also used with equations. So what equations do is they can create relationships between variables. So let's say you need a dimension to always be 2 times another dimension. You can use equations. A powerful application of these can be generators, which uses a set of equations to generate common parts like gears. So for example, if you want, a certain tooth profile in a gear, you can put that in and you give it a certain amount of teeth, and a gear generator can use the equations and variables to just create that gear for you automatically. So here's some other tips for CAD. My number one tip is to try to avoid being lazy. So for example, keeping drawings undefined or not making parts in assemblies. These can cause massive problems down the line if they're not addressed early. And these are all in the effort to save time. So let's go over that more. Saving time. In robotics, the two most limited resources tend to be time and money. However, time is often the most overlooked. Designs need to be done quickly so the robot can be built, programmed, and tested before competition. Saving time is essential for a competitive team. So for example, if you're talking about design, all of this stuff in this entire course needs to be done in less than 3 weeks. So that can really, get into your head, like how much time do we have? Very little. So we need to do all we can to save time in the design phase. So here's some methods to save time. Excluding the methods outlined earlier in project management, we can download pre-made models, not fully CAD parts that don't need to be, rapidly prototype, and buy needed parts early. Downloaded pre-made models. Oftentimes in robotics, we aren't making everything in-house. Almost every team buys gears, bolts, nuts, and bearings from stores, and some teams even buy extrusion and whole mechanisms. If you are not building it custom, try downloading a CAD model from the manufacturer's website. The best place to find parts and models is McMaster-Carr. If you don't know what it is, and if you're in robotics long enough, you will know what it is a giant online retailer for everything mechanical. They also have CAD models for every part and have an add-on for SolidWorks. It is especially useful for bolts, gears, bearings, and other parts that are time-consuming to model by hand. Basically, if you have a common item and you need the CAD for it, just check McMaster-Carr first. It makes things a lot easier. Another tip is to don't fully CAD everything. Sometimes parts don't need as much detail in CAD as in real life. Not every bolt needs to be inserted in CAD, and hollow 2x1 tubing doesn't need to be hollow in CAD either. This both can save time designing and, more importantly, can save computer resources, which also takes time loading the file. If you ever tried to work with a SolidWorks or any CAD file that's very heavy in design, very complicated, it makes your computer slow. All that time you're wasting with lag and loading time of parts is time you could be designing. So making simpler parts is better. The next tip is to rapidly prototype. Now we are trying to avoid redesigns. Rapidly prototyping can save massive amounts of time designing when you realize an idea doesn't work. Prototyping is essentially the insurance of robotics. You're spending a little bit of time and money to prototype, but in exchange, if an idea doesn't work, you save massive amounts of time. Remember that the key word for this is rapid. Use cheap materials that are easy to fabricate quickly. So if you remember the materials course, wood or MDF mostly. You can also use pre-made parts to simulate mechanisms. So if you just have, random robotics parts from previous years that are similar, or just things laying around that could be useful, you can use those for prototyping. Some teams even use things from the gym, like a treadmill, to help with their prototyping. So the last tip is to buy needed parts early. Most designs share similar part lists, so you should go ahead and order those as soon as possible. For designs with specialized parts, you should wait longer, but once your rapid prototyping is done, order the parts. You should avoid ordering parts last minute. So if you think you'll need a part at all, I would just go ahead and buy it. The worst that happens is that you need it a year in the future. Once again, the other thing I would say is if it's a very specialized part, maybe try to rapidly prototype before you buy the specialized part, because you don't want to waste too much money. Any questions? Okay, final section, designing for manufacturing and maintenance. Designing for manufacturing. When designing parts, the method of manufacturing should always be thought about. In CAD, it is easy to make an impossible or difficult to manufacture part or assembly. Figure out how you'll make a part early to avoid this fate. So what are the types of manufacturing? The two most common methods of manufacturing in FRC is CNC machines and 3D printing. So when I say CNC machines, it's mostly routers, mills, and laser cutters. When I say 3D printers, it's 3D printers. CNC machines are good for larger parts, and 3D printing is good for complex, smaller parts. So designing for CNC machines. When CNC machining, especially with routers or laser cutters, the complexity of the cut part is limited. Overhangs are either extremely difficult or impossible. Corner radii are limited by drill bit diameter. So essentially, the radius of the drill bit is the minimum possible radius of a corner. And you cannot cut sharp corners, so you have to have some sort of fillet. Possible depth is also limited by the machine. So you cannot have like a giant block of wood in a CNC router. It's not going to be able to cut all the way through. And in a laser cutter, the laser strength is limited. So I would just recommend, if you're using a CNC machine, make sure to consult an actual expert on that machine on your team, like a mentor or a veteran on a team who knows whether or not something can be manufactured. Another reason why you should have a project manager and have communication within your team. So now we go over 3D printed design. So we've gone over many details in the earlier materials lesson, but here are some additional tips. Cut larger parts into smaller prints that can be combined together. When doing this, add slots or other means of alignment. And then finally, you can use glue or bolts to combine the parts. Now, if you weren't here for the materials lecture, the general summary is just make sure that there's flat sides of the 3D print that can be on the bottom, and to avoid overhangs and things that need support, because support's annoying. But designing for 3D printing is pretty easy because 3D printers can do a lot of things. So now we'll go over designing for maintenance. Good maintenance design is a lifesaver during competition, as robots can and will break. Designing for maintenance both decreases the chance of breaking, but also makes fixing these problems quicker. So how do we do it? The main method you can employ to make easier maintenance is designing for wiring, choosing the right fastener, so rivets versus bolts, limiting tight spaces for bolts, and allowing easy but protected access to electronics. Designing for wiring. When designing mechanisms, try to think how wires will flow through the robot. So add holes for wires to feed through or slots for zip ties and Velcro. You can feed wire through tubing, although this is not recommended without pocketing first. So essentially, if you just have a giant tube that's completely solid, probably shouldn't put any wires through. If you do, make sure to solder them and don't have non-soldered connections, because it'll be very hard to access those. If you do pocket them, it's much easier to access them. Choosing fasteners. Parts that will likely need to be removed should use mainly bolts, while parts that you never want to break should use rivets. This is because rivets require the use of a drill in order to be undone. However, when putting them on, riveting can be faster than tightening bolts, and they're also lighter. So you should most likely use rivets for everything that you don't want to come undone, and be on the safe side towards rivets because they're faster and less annoying. But if you know for sure something will have to come down, either because if something breaks or just because you might want to, swap things out in competition, you should use bolts. So giving bolts space. Whenever bolts are used, there should be adequate clearance in order to use wrenches and T-screws. In general, try to avoid placing bolts in hard to reach places, as they can be extremely painful, mentally and physically. I can't tell you the amount of hours I've had just trying to go into a hard to reach place in the robot and tighten a bolt because I was stupid and I didn't put the bolt in a good place to tighten. It also makes competitions a lot more fun. Access to electronics. Electronics should always be easily accessible on the robot. This likely means having a section of the robot dedicated to them, so a belly pan or a part in the back. However, they should also be protected from dust and debris, as they can be fragile. So I think the easiest solution to this is to have an area for the electronics and then cover it with some plastic sheeting like polycarbonate or acrylic, and have Velcro to act as the cover. Any questions? Somebody asked, what does it mean to pocket wires? I don't want you to pocket wires. I want you to pocket the tubing. So if you don't know what pocketing is on a tubing, you basically cut out parts of the tubing without cutting everything to make it lighter. The benefit there is how you have holes in the tube that you can use to reach inside and interact with the wires if need be. Any more questions? Okay. So end of course thoughts. It has been really fun making this course for everyone watching this. I really hope this course is useful for anyone who wants to get into mechanical design, especially in FRC. My main takeaway here is that you should take everything you learn in this course and expand upon it. There's many resources made for members in the FRC community or the engineering community to learn more about any of the topics discussed within the last few weeks. Some examples of those are Chief Delphi, Reddit, there's books on mechanical design. If you look at all of those, you can learn more about this very special subject. I also want you to know that this is a fun process. It might seem complicated, especially during the physics section. But just remember that this is a creative process where you get to work with other people and make dreams come into reality. And especially in FRC, just to do useless games. So it's very fun. I really hope that whoever watches this has a good seasons upcoming, or in this case, enjoys their newfound knowledge of engineering. And goodbye.